Hi, I'm Baba. Today I'm going to explain you how to analyze the IRC data by using the MATLAB. There are many companies in the market which provide an equipment that acquires depolarization current of the cable with respect to the time. Ciba KMT is one of the company that provide you a system which acquires IRC data, and their system also analyze it. But sometimes when your cable are not according to the standard or custom made, then you will not get an appropriate result by the system. In this case, you have to analyze it by yourself. This video will give you a brief idea that how will you find out the two major methods which are used in IRC analysis. According to the literature, there are two major methods that are A-factor approximation method and T-max graphical method. So before starting data interpretation by using MATLAB, I highlight over the basic of both the methods. In A-factor approximation method, we actually fix a curve on the data that we get from the system. Usually this kind of file is received by the system. Time against the depolarization current. Data file from the IRC system have acquired the depolarization current against the time as shown in this figure. The above equation is used to fix the curve, and the constant obtained after fixing the curve are used in finding the A factor. So, A factor is actually a ratio. A ratio between the charge area under the TOR3 to the charge area under the TOR2. However, for the Tmax, we plot I into T curve against the logarithm of the T and find out the corresponding time at which the maximum value of I into T exists. This method is called geographical method of finding out the Tmax. Once A factor and Tmax are evaluated, then these are the criteria given in the literature for the analysis of the cable. A factor less than 1.7, perfect, greater than 2.1, critical. And similarly, Tmax greater than 700, very critical, and between the 300 and 700, it means the cable is in critical zone. Now, how we can find out the A factor using the MATLAB? As I told you, I have already get the data file from the system which have the value of depolarization current against the time. Now, I will got from the IRC system. This data file have current time value and the current value. Now, how I can import this data file or data into a MATLAB? First of all, you put the location of your file here in the current folder, and you can see that your file will appear in the current folder dialog box. When you double click it, your data will be imported into a workspace of your MATLAB. Now you can see that your data file is imported in the workspace, and you can also see it in a variable editor. Now my first step is to separate the values of time and values of current in separate variables. Now you can see that the separate variables of I and T is generated. If I plot the current I can see the plot of depolarization current. As you remember, that now this curve has to be fitted by using this equation. In terms of MATLAB, this equation can be written in this way. So I will copy it from here. Now I'm going back to the MATLAB. In order to fit the curve, I'll go to the Start, Toolboxes, Curve Fitting, and Curve Fitting Tool. So I'll have a curve fitting tool. In this curve fitting toolbox, I will click on this new option. So I'll have a new curve fitting tool space. In the X data, I'll select the T, and in the Y data, I will select the I. So now I can see my curve of I into T. But to get it fit, I have to change it to a custom equation. Since I have copied the custom equation from there, so I can paste it here. Now you can see it fits the equation properly, and its R square is 99.97. But according to the literature, the values of the T1, T2 and T3 are actually bounded. So in order to bound them, I'll uncheck the auto fit button, go to the fit options, and unbound the T1, T2 and T3. Now I unbounded these T1, T2 and T3 according to the values given in the literature. For better results, I'll increase the maximum function evaluation and the maximum iteration. I'll close it and press the fit button. Once it's done, after fitting the button, it will fit the curve. And now you can see that your T1, T2, T3 is under the bounded values. And your R square is again 99.97%. It means your curve is properly fitted. So what I'll do, I'll copy these constant values, because now I'm going to use these constant values for the A factor evaluation. Because you remember that for the A factor evaluation, you need the values of A1, A2 and A3, T1, T2 and T3. This equation could be written in the MATLAB in this way. Now I will fill in the values of constant here. Now you can see that I have filled the values of all the constant here. Now the values of the constants are filled in the equation, and that particular equation, as I told you, the A factor equation can be written in a MATLAB in this way. So my MATLAB code is ready. I will copy this whole equation and will paste it in the command line of the MATLAB. Once this complete equation runs, I can see that my A factor is evaluated, and it's found to be 2.9715. So according to the criteria, my cable is under the critical zone as per the A factor approximation method. Now I'll tell you how I will do the graphical method using the MATLAB. As I told you, for the graphical method, we have to evaluate I into T. So I have to evaluate another variable which will have a data of I into T. So I will write IT dot star is a way for element to element multiplication in MATLAB. This I of T will actually the same multiplication I into T variable. Now to see that how the I into T exactly look like, I will plot it. This is a curve of I into t against time. If I need to see I into t against the logarithm of the time, then I have to select the semi-log x of I of t. Now I can see that this curve is similar what I have shown you in the presentation. Now my way the t max will be somewhere here. So in order to evaluate the data or the value of the t max, I will find out the maximum value of the I into t and the corresponding t max to it. For that, I will be using this MATLAB code. I have already shown you that how I evaluated the I into t, and I also tell you the semi-log of x will give you that curve of I into t with respect to the logarithm of the time. Now in order to find out the t max, I will evaluate. So once I copied this equation from here, I will put it and paste it in the MATLAB. So it's executed. And I told you that what this command is actually doing. It's finding out the maximum value of I of t. These particular values getting two different data. The value is getting the exact value, maximum value of I of t. And the t1 is getting exactly the index corresponding to that maximum value. So if I got the index, I can reach to the t max by putting the index in data file, and since 1 is the first column of the data file has the t value, current time value, so with that data file I'll get the t max value. So now my t max value will be, the evaluated t max value is 476.02 seconds. So with the criteria, I can see that it is between 100 to 300 to 700. It means this cable is also critical. My A factor approximation will also tell me that the cable is critical. And my graphical method is also saying the cable is critical. It means the data I have of any particular cable, after an evaluation, it seems that the cable is critical. So in this way, if you got the data file of any of the cable, you can easily evaluate the A factor and T max of that particular cable. And once you have the A factor and T max of that particular cable, then you can analyze it and come up with an approximate estimation that how is the health of your cable. I hope this set of videos will be helpful for you in analyzing the IRC and evaluating the A factor and T max using the MATLAB. Thank you.